Prism volume is figured out in a very cool way. Prisms, because of their identical bases, one of their characteristics is that they have a base that has a partner, a parallel partner, on the opposite side of it, can be calculated volume-wise as kind of what we call the stacking principle. Think about it this way. If you found the area of just the base, that little base down here, and if you stacked that shape on top of itself over and over and over, you would get volume. You would find everything inside of that shape. So if we take a look here at another example, you can see how if I found the area of just this hexagon, one area, and then stacked it over and over, it would fill that entire space. So guess what? Volume of a prism is its base times its height, area of its base times its height. And again, the principle behind this is what I call the stacking principle. And here's another example, just same idea, where that base, that triangular base, would stack over and over and over again. So when we talk about a prism, just maybe let's speak about a few things. The bases are the two identical guys that are always opposite and parallel. The other sides are known as the lateral sides. So the three sides, and I can't really show them very well here, but there are three sides. The one in the front, this guy right here, would be a lateral side. And then the guy around this corner and the guy around this corner would be the other lateral. So two bases and three lateral in this particular prism. So the relationship here is really quite nice in that all it is that volume is one base times the height. Now the height, we often think of the height if we have a person standing here. We say, oh, what's their height? We say, this is their height. Now in the case of a prism height, it is the distance between the two bases. Now if you look closely at the guy that we have out here right now, this guy actually has many potential bases, the front and the back, the top and the bottom, the right and the left. And so in this case, you kind of get to pick your base. I'm going to pick the one that's been shaded, this front side. And so if I was doing this, it would be volume equals one base area times the height. Now, this base area is a rectangle, so that's easy. That's just 6 times 20. That, again, all of that is the base. And then my height happens to be 14. Now, that's the part I want you to focus on. Why is it 14 and not 6? You might say, hey, 6 is the height. Because I called this my base that I calculated, then the height for me, by my base picking that, is this guy along this edge here. So that's what it would be. And I would multiply those together to get my volume. We're doing volume now, which is cubed items, right? We're finding how many cubes fit inside of that guy right there. So again, we move to the third dimension in doing so. What I love about this formula is that it's generic. In other words, it works for any kind of base, right? It's just one base area times the height. Now in this case, our base, the two parts that are identical, is this guy and the back guy. So I'm going to work with a base that is a triangle this time. 1/2 little b times h. That would calculate my base times the height, and this height is referring to my prism height. One thing I did notice, and they love doing this, is that this is a 5, this is a 13. I'm missing this length. And if by now you haven't learned that 5 squared plus 12 squared equals 13 squared, you need to memorize that relationship. So let's start plugging in numbers. Volume equals the base. So the base is a triangle. So it's 1/2 5 times height 12 All of that represents the area of my yellow triangular region. And I'm going to stack that over the height of 15. Let's do a quick analysis of this. The first part calculates my base, right? That's my base right there. The second number, 15, is the height. Why would that be my height? That is the distance between my two bases. And with a little bit of mathematics, we find the volume to be 450 centimeters cubed. We are progressing in difficulty, and that's the way it should be. You'll notice that my prism, of course, has two identical bases, and it would be the front and the back in this particular case. And so I need to find, again, to do this, I need the area of one base and stack it over the height. Now this guy is a equilateral, and I know a little bit about that. I know that there's a little triangle in there that's a 30, 60, 90. And if that's 6, this would be 3, and then that height of my triangle would be 3 root 3, right? Because this shape right here is a 30, 60, 90. So let's plug it all in. My base is a triangle. It would be 1/2 the base, which is 6, right? 6 times its height, which is 3 root 3. All of that was just to get my base, and now I'm going to stack it over a total of 10 centimeters. And when I slam that in the old calculator, I get 90 square root of 3 centimeters squared, cubed, careful, because this is a volume calculation. And then when I calculate that out, that roughs in at 155.88 centimeters cubed. This is known as an exact answer. This is known as the decimal approximation. Let's do one more. All right, a hexagonal prism. What that means is that the bases that are the same, the top and the bottom in this particular case, are regular hexagons. And it actually needed to say regular hexagon there so that we would know what we're about to do. Now, we need to find the area of this base. Now, I've done a little bit of prep work for us. Do you remember this formula? It's 1/2 the apothem times the perimeter. And I already did a little bit of work for us. Do you see there the 6 got cut in half to get 3. I multiplied by root 3 to get my apothem. So my apothem is 3 root 3. My perimeter would be 6 times 6. All of that work, again, is 36 times 3 divided by 2 is 54 root 3. That's what all of that is. Now, let's go back to the main formula, which is volume is one base stacked on its height. Now, that is this number, which is our hexagon value, multiplied by a height of 10. Hey, that's easy. 540 root 3 centimeters cubed. And again, you can turn that into a decimal if you would like. But really what I want you to notice is, do you see how we're mixing all of these things together? We needed to be able to find this concept. We needed our apothem. We needed our perimeter to get our overall answer for that. And then now we know our area of our base. Prisms are quite simple because of this stacking idea. And all it really is an area times a height. Very simple.